All right, let's get right into it. Preventing duplicate bookings. This is one of those system design questions that looks super simple at first, right? But it's actually a really clever way to check if you truly understand concurrency and consistency. Nail this, and you're basically telling the interviewer, yep, I'm a senior engineer. And I'm not kidding. This isn't just some textbook problem. Major tech companies like Tesco use this exact question to find the best candidates. They want to know if you can build real-world systems that don't just fall over under pressure. So let's break down exactly how to crush this answer. So what's the big deal here? Well, the entire problem really boils down to one critical concept: the race condition. This is what happens when two or even more processes try to grab and change the exact same thing, in our case, a single seat, at the exact same time. So let's paint a picture. Imagine tickets for a huge concert just went on sale. They're selling out fast. User 1 sees the perfect seat, A1, and they smash that book button. Great! Their request is on its way to your server. So far, everything is fine. But, and here's where it all goes wrong, at the exact same millisecond, User 2 also sees seat A1 and hits book. Now you have two separate requests, both for the same seat, racing towards your system. And boom, that's the nightmare scenario. If your system doesn't have any safeguards, both of those requests could check the database, both could see that seat A1 is available, and then both could go ahead and book it. What do you get? A double booking. You've got two angry customers, a huge mess to clean up, and a serious problem with your system's integrity. This is exactly what we have to stop from ever happening. Okay, so how do we fix this? Our first layer of defense, and honestly, this one is non-negotiable, is to use the database itself as our ultimate guardian. This is our safety net. We do this with something called a unique constraint. We're basically telling the database, hey, for this specific combination of a show ID and a seat ID, there can only be one entry in this table, period. It becomes the absolute source of truth. So, back to our race condition. Even if both requests somehow get past all our other logic, when that second booking tries to write to the database itself will just slam on the brakes. It'll see that the unique constraint is about to be violated, and it'll throw a duplicate key error, rejecting that second booking flat out. It's a powerful, bulletproof final check. But here's the thing. Just relying on database errors, it works, but it's kind of clumsy. It's inefficient. You're making the database do all this extra work, throwing errors, rolling back transactions. It's just not clean. A real senior-level answer introduces a smarter, faster, more proactive layer before we even bother the database. And for that, we're going to use a distributed lock, probably with something like Redis. The logic here is actually pretty simple, but it's incredibly powerful. When a user tries to book a seat, our service first says, hey Redis, can I get a lock for this specific seat? The very first request to ask gets it. Anyone else who comes along a millisecond later and asks for the same lock is told, nope, sorry, someone's already working with that seat. Try again later. It's like a one-at-a-time gatekeeper. The secret sauce is in the command itself. We use set with a couple of really important flags. NX is the magic here. It means only set this key if it does not exist. That one command is what makes this whole thing atomic and prevents the race condition. And EX10, that sets an expiry of 10 seconds. This is a critical safety hatch, so if our service crashes, the lock is automatically released and doesn't get stuck forever. So now we have our two layers, right? We've got the super fast proactive Redis lock that handles the problem at the application level, and we've got that rock-solid database constraint as our ultimate failsafe. The real key to a senior answer is showing how you blend these two together. So let's craft that perfect response. And there it is. That answer is just perfect. You know why? Because it shows you think in layers. You lead with the fast, efficient solution, the Redis lock, which gracefully handles 99.9% of cases. But you also show you're thinking about worst-case scenarios by including the database constraint as that absolute guarantee for data integrity. It proves you know how to build systems that are both fast and correct. And that's really how you build a robust system to prevent duplicate bookings. This pattern, combining a fast, proactive lock with a final database guarantee, is fundamental to so many distributed systems. So the question I'll leave you with is this. What other things in a big booking system might be vulnerable to a race condition? Think about ticket inventory levels or maybe a limited number of promotional codes. How would you protect those?